Hi everyone, welcome to Elastropy. Today we have an exciting tutorial for all you OpenSees enthusiasts out there. In this video tutorial, we delve deep into the world of Tcl and Python commands of OpenSees and learn how to find their corresponding C++ source files. Well, if you are into structural engineering or earthquake analysis, you might have already understood that OpenSees is an incredibly powerful and flexible software framework for simulating the behavior of a variety of structural systems under static and dynamic loading conditions. Understanding its C++ source code can be incredibly beneficial for research, customization, and optimization purposes. This tutorial comes in two parts. In the first part, we will explore the process of finding C++ source files behind TCL commands, and in the second part, we will explore the process of finding C++ source files behind the Python commands. Let's jump into the tutorial. For demonstration purposes, I downloaded the TCL and Python input files from OpenSees documentation websites. For TCL, I am using this example 4 input files, and for Python, I'm using this example 14.1.3 portal frame 2D analysis files. I downloaded those files and kept in my local directory. So this is where I kept my TCL files, and this is where I kept my Python files. I linked these input files to the source code in Visual Studio. This is how I mentioned the paths and the file names of TCL input file and its location. And this is how I put the file name and the locations of Python input files. If you are new to this tutorial series, you will find this linking process in two of our earlier videos. You will find these videos on our Elastropy channel. So this is the video in which I clearly explain the process of linking and debugging the source code using Python input file. In this video tutorial, I explain the process of linking and debugging the OpenSea source code using TCL input file. Go through these videos before watching this present tutorial. Yes, that's it for the intro. Let's find the C++ source files corresponds to TCL commands. If you want to know what is the source file behind this concrete02, let's just copy this keyword and press Ctrl F, paste this command here and use entire solution and click this find all. You will get all the list of files wherever the concrete02 keyword is used. So I'm going to find a file wherein all the TCL commands are written. This one, TCL model builder uniaxial material commands. So let's search for concrete02 within this document. Yes, here. So here it is coded like if the first argument of the command is equals to concrete02 where C is a capital letter, then the pointer, the mat is set to OPS underscore concrete02. So just put a breakpoint here and run this debugger, and it stopped here because a concrete02 keyword is mentioned in the input file. That's why it stopped here. Let's go into this OPS concrete02. That's it. You entered this concrete02.cpp input file. So this is where the detailed code for concrete02 material model is defined. For every CPP file, there is a header file also associated with that. So let's open it. Concrete02.h. This is the file. So in this concrete02.h header file, the class definition is presented. So here you will find all the member functions and member data of corresponding to this concrete02 material. Similarly, if you want to find the source files corresponding to this, for example, this nonlinear beam column element, just copy this keyword and I'm closing all these files. So also I'm stopping this debugging. Just press Ctrl F, paste it here and find all. just like the TCL material, uniaxial material commands, you will see a TCL element commands. Yes, this one. So here the keyword nonlinear beam column is compared to the input argument list. I'm putting a breakpoint here and running this local Windows debugger. Yes, it stopped here. So here a function called TCL model builder underscore add force beam column is called at this location. So let's go into this by pressing either F11 or this step into navigation key. Just I'm going inside. So here we have to find the exact function that is called. So come down. Here all the integration schemes that are used in this element definition command are given. Here on line number 421 we have a variety of elements comparison happening. So I'm putting a breakpoint here. So and then pressing continue button. So just I'm pressing step over or F10 key. So I'm just getting into this. So our keyword is not elastic force beam column. Also our keyword is not a Timoshenko beam column. Similarly, these are not all the keywords that we used. We used a specific keyword called nonlinear beam column. So if our keyword doesn't match with all of these, so it is suggested to go into this force beam column 2D. So we are going into this. Yes. So the file that is used for this nonlinear beam column command is this force beam column 2D. I put a breakpoint here and then for now temporarily to see whether this is the exact C++ source file that is called or not. For now temporarily I am disabling all the breakpoints that I set in other files. So you can disable them by checking into this breakpoints pane and disable all of them except the one that we kept at line number 678 of this force beam column 2D. Disable it, disable it, disable it. That's it. And now I'm just stopping the debugging. So now we have only one breakpoint that is at line number 678 of this force beam column 2D. Let's run this local Windows debugger. Yes, it stopped here. So it means like whenever you use this nonlinear beam column keyword in this TCL input file, inherently the function that is used is this force beam column 2D. So here you can find its class definition as well. Force beam column 2D.h. This one. So this is the class definition for this force beam column 2D. Here you will find all the member functions and member variables that corresponds to this element definition. Similarly, you will find the corresponding input files for any OpenSees command defined in this TCL input file. If you have any questions or suggestions, we recommend you to please write them in the comment section below the video. We greatly appreciate your feedback and we will do our best to respond to each and every comment. If you like our content, please hit the like button and subscribe to our channel. Happy learning. Thank you.